morning. This question is for the students who are doing mechanics. It is the topic of impulse and average force. You can see the situation. The truck is initially moving with a velocity vt and is fast approaching a buffer. Okay, so we are making the truck crash into this buffer kind of spring, and this truck is moving in this direction. Okay, so this is the way it moves, and finally the truck collides with the buffer and the buffer gets compressed. Okay, so now the truck is stationary. The question is, what is the impulse which is delivered to the truck? And remember the structure, this particular structure is a wall of infinite mass. It cannot move, it is stationary. The buffer is massless. Okay, massless. So practically the buffer and the wall system, if I were to take them, we are not concentrating on them, we are only concentrating on the truck. I hope the situation is clear. In this video I will bring up one topic after another. Listen to each of the topic first before we start solving the question. I hope this helps. Okay, just one important point. So if the collision starts at time t is equal to 0, now the spring and truck are in contact with each other. They stay in contact with each other for some time, and at the end of this collision, when the truck comes to stationary, this final state, the total time elapsed is t. This time, which elapses from t equal to 0 till the time the truck comes to standstill, is called as the contact time. Both the buffer or the spring, you can say, and the truck are in contact throughout this time. Contact time is this. You must understand contact time very well. Okay, so one of the doubts students have is whether we can apply the concept of impulse to a situation where there is a wall which is stationary and the other body comes and collides with it, which is A. And the second situation is both the bodies are moving and collide, right? We are only studying this one currently. This mass behaves like a truck, and this is the infinitely large wall. We are not studying this one. Second block B delivers an equal impulse to A. So you can apply the concept of impulse to both one body is stationary and one body collides with it, and the second situation where both the bodies are moving and collide with each other. So just one important point, when the block or the truck collides the wall, okay, there is a mutual force between them, which is action and reaction. Action and reaction. Okay, there is no external force which is involved. So whenever you're doing impulse questions and calculating the average forces, remember all of that is happening between two bodies, and that force is action and reaction. The average force which is being referred to. Okay, we're finding the average of that, but the external force involvement is not there. So you need two bodies, a wall for example and a block, to be solving impulse questions. Similarly, when you strike a ball on the surface of the earth, you have two bodies, earth and the ball. The ball comes back after striking, right? So remember, there is no external force involved in these questions. The change in momentum, all right? So the change in momentum, all right? One more term, change in momentum, all right? So I started with momentum, but actually it's change in momentum. So if you have to link impulse, average force, it is linked to change in momentum. The change in momentum that happens, right, is also called as impulse delivered. Impulse delivered, all right, impulse delivered. Now, when the truck was moving, what was the final momentum of the truck? All right, let's say what is the final momentum of the truck? See, it is m truck multiplied by the the final velocity of the truck. So this is the P final, right? So this is the final momentum of the truck, where Vf obviously is the final velocity is 0. What is the initial momentum of the truck? M truck multiplied by V initial. So this is P initial. All right. So if you have to calculate the change in momentum, all right, let's say you have to calculate the change in momentum. Okay, this is just the part I have not. So let me just tell you what exactly does it amount to. So delta P, which is change in momentum, is equal to P final minus P initial. And if you notice this, it will be M into 0 minus M into Vi. So this is the mass of the truck being referred to. So the truck has undergone a change in momentum. Okay, so the truck undergoes a change in momentum, and this momentum, right, is the exact physics is the change in momentum is referred to as impulse delivered. So impulse is delivered. If that impulse is delivered over some time, which is called the contact time, which I told you, right? Then the rate at which the impulse gets delivered, when I say impulse is delivered, I mean change in momentum. When I say rate of impulse delivery, I have to divide this by the contact time. That is called as the average force. Okay, and you also write delta P, which is change in momentum, as the J, which is your impulse delivery. So J by T is equal to F average. All right, so one of the queries a lot of students have is why the word average is used. Okay, the reason is the force, which is the mutual force between the truck and the buffer, is average because it is variable force. It reaches, it starts from 0 maybe, and it then reaches the highest point, then it goes back. You can see it's a time varying force. Okay, as the time is progressing, the force is changing, and therefore the force is a variable force through the time, and we find the average of this, and the average is what we are interested in. Okay, so the concept we are studying does not involve a fixed force. So just one word which I want to say is on the time. Okay, generally you will find this time, which is a contact time, to be very small. Okay, very small in magnitude, but it is not necessary, right? When we study strictly, we say this time has to be very short, but in certain numericals, like you will see this truck, the duration of contact may not be 1/800th of a second, but can be 8 seconds also. Feel free to apply the same principle even if you find the time is very large, which is a contact time, and you see the words like average force, impulse, change in momentum being mentioned in the question. Okay, so let's summarize how we will solve the problem of truck. So let's say the truck was coming with initial velocity. Okay, V truck initial was 10 meter per second. After collision, the final velocity of the truck is 0. The mass of the truck is 8,000 kilograms. What is the change in momentum? The change in momentum is given by M final, sorry, P final minus P initial is equal to 8,000. 0 minus 10 is equal to minus 80,000 kilogram meter per second. This is a change in momentum, and the buffer got compressed to its final state, where the truck comes to rest in time is equal to 4 seconds, right? So this is your contact time being referred to. You have to find the impulse which is delivered. It is same as change in momentum. Okay, part 1 done. For the second part, if you have to calculate F average, I told you have to calculate the rate of change of impulse delivered. or the rate of change of momentum. Impulse delivered divided by time is same as delta p by time is equal to 80,000 divided by 4 is equal to 20,000. So kilogram meter per second square, same as the unit of force.